to start with an introduction. My name is Dave Martin. I'm from Austin Mac Incorporated. We designed the screw conveyors for the amendment bin right here. And we also did all the structural engineering and fabrication of the 2 amendment bins and the 3 biosolid bins. Spirac is the manufacturing of the shaftless screws in the 3 biosolid bins and the in-kind discharge screws into the belt conveyors right there. Little background. So if it gets too noisy here, we'll kind of go downstairs and quieting down a little bit so it's a little better. Let's see. Just kind of follow through on the outline right here. So I'll talk about the amendment bins first. They're designed to handle about 200 cubic yards of amendment. We have the grizzly decks are removed right now. They're actually over there stacked up if you want to take a look at those. They're in 6 pieces that just sit on top of the square tubing on the top. They're real easy to take off and put on. And they're there basically so when you dump the material onto the top, anything larger than I think it was 6 inches or so, I forget the exact size, will basically roll off and dump down here in the bottom. So it acts as kind of a screening member and also kind of a little safety cage there as well. They're designed to take, you know, some of the bucket load. If the bucket does hit it, it's not going to really affect the grizzly deck at all. Let's see, on the bottom of the bin there's 4 live bottom screws. And what they are is they're a variable pitch type screw where it starts out on the far side, on the inlet side, as a narrow pitch. And then it gets wider and wider as you progress to the discharge. We did that so that the material evenly is taken from the bottom of the pit. If there are constant pitch, the material basically would only feed from one side and you kind of create a hole. This helps eliminate bridging type problems and so on. So it should take the material down evenly across the whole length of the screw.
Pardon me. That protective grid on top is to prevent large material from going down, I suppose, to protect the screws. Is there some specific sizing that we need to be concerned about that'll stop the screws from actually, you know, moving the material along?
Well, there's about a 1 to ½ inch clearance. I think more like a 1 inch clearance in there. So it can really handle big chunks and so on. You know, if you get something really big, it might jam at the shroud, and you can reverse it and try to get it through and stuff like that. I mean,
it's like a 2x4 by 10. If that got in there, is that going to stop this thing?
A lot of times it will shred it. These screws are really strong. They're on 16-inch pipe, skid-ready pipe, and there's over ½ inch thick flight, so they're not really a tall flight either. So it should shred most stuff. Okay. You know, rocks and hard things.
That's what'll stop it and jam it up.
If you get something too hard or too big in there, then the thermostat should kick out and tell you, you know, you have to clear it or do
thermostat
something.
in the gearbox or what thermostat?
In the control panel. I'm pretty sure the thermostat is on the variable speed drive. On the variable speed drive, in the panel directly below.
Because it'll be working harder to try to push something hard out, and that'll heat it up, you mean? Okay.
Correct. Yeah, the amps will go up, and at a certain rating, it will tell it to basically kick out.
Okay.
Are we concerned about the weight? If we fill a hopper all the way full, is that going to affect?
You can fill it all the way, and it won't affect it at all. It's designed to be completely full and still handle the head load on the screws.
Okay.
And the pipe in the screws are designed for the deflection of the head load, so it's not going to deflect very much, even completely full.
Okay.
You know, unless the material gets really out of spec, you know, it's really heavy or something. But
we get a choke, we have to empty the whole thing.
If we do get too much load on that, in order to restart the augers, do we need to empty the hopper completely?
No, I mean, the screws and the drives are designed to handle the load. If you get like a jam, something that's not supposed to get in there, which is hard to get through the grizzlies, then maybe one screw might get blocked, but the other screws should still be able to work.
Okay.
We designed them with independent drives on each screw.
So we could
run, say, 3 screws one is jammed.
So we could empty the hopper and then go in there and retrieve the contamination.
Correct, yeah.
Okay.
You wouldn't necessarily have to dig the whole thing out to get a jam out.
Excellent.
We tried to make it as easy as possible for problems and stuff, so you can run each screw independently.
If
Excellent.
you did have to dig it out, what systems are to pull it out besides hand? I mean, there's, you know, in the industry, any sucking type pumps so you can pump the stuff out, or?
Yeah, you can get like a big back truck in there, and that should suck the stuff out. You know, you can even get like a loader bucket or something like that. I mean, not the loader bucket, but the excavator bucket and dig it out.
That's what people have done around the country, that you have to get in there.
Yeah, they try to get the screws to go out first and do that. You know, if you get a jam where the shroud is, you know, as you can see, the discharge is right below here, and there's some shrouds there to prevent material from overflowing the top of the screws. You could remove those shrouds and run it if the jam's at the shroud without having to unload the whole hopper. And I'll go through that a little bit more in detail later on. Okay, the question here is what happens if you get a jam and you have to reverse it? Where would you actually have to go to do it? I wasn't involved in the controls, but I'm pretty sure I can answer this one. You would have to go to the control room to do a reverse. There's not necessarily controls down below. You would not have to reverse any leads on a motor, like, you know, because there is a variable speed drive, and in that system they should have a reverse on it and stuff. So it should just be something the operator in the control room would be able to take care of.
I don't believe the SCADA system has a control to run these things forward and backwards, although they do have a speed control. But I know that there's a motor control panel local here, and I don't recall if that has forward and back, but I know the motor control room does have that.
I'll get back to the screws. So yeah, it's designed with really strong pipe to take the head load and the torque on there. Flights are 1/2 inch thick. And all the screws are identical. They're all the same hand, same length, and everything, so they should be interchangeable from one to the next. They're supported on both ends with double spherical type bearings. On the tail end, there's a packing gland seal, which is like a braided type packing, 2 rows, and a pressure plate. And once the packing wears in a little bit, you can adjust the pressure plate in and keep the seal tight. And I'll go down and show you where that is and such when we get into the maintenance and
Okay.
stuff. And basically a pillow block bearing. The tail end is the expansion end of the screw, so if it does heat or shrink, it will expand on the tail end. On the drive end, there's also just a plate seal with a lip type seal, and then a flange type bearing, a 4-bolt double spherical flange type bearing that can take a lot of misalignment and also thrust. And the drive end is the fixed end of the screw. So there is actually a snap ring on the shaft that will push the thrust against the bearing itself. And then there's another spacer which the drive comes against the spacer and keeps the drive on the shaft. The drives themselves are 15 horsepower motors. They're the explosion-proof type motors. They're Toshibas, and the drive is SCW Euro drive. It's an integral gear motor where there's no shiv, hubs, and belts, and it is mounted to the system with a torque arm. So if the drives oscillate a little bit, they're designed to actually move depending on the loading on the pipe itself. And it's better to have a long span type screw with a shaft mounted torque arm drive so that the bearing isn't taking that bending load right there. So if you do see the screws oscillate a little bit, it's not a concern, it's designed that way. And so we've done some test running. They're sitting pretty straight. They don't move very much at all. You have to really get up close to see them move. So they're aligned real well inside the pit right now.
Is that something you would see over time? They would move more as wear and tear to the screw, or how would that work?
Well, as you get more loading, if the hopper is completely full, you'll get more bending on the pipe of the screw. So then as you're bending, it wants to do a motion like this. So the more load, the more motion you should get.
Okay.
But even under full load, the bending shouldn't be that much.
Okay.
So, and again, it's a double spherical roller bearing there, so they're meant to take a lot of misalignment and still function properly.
And they have enough torque to start and stop under a full load? The screws?
Yes,
Okay.
absolutely.
122 to 1.
What's that?
122 to 1.
The
reduction.
Yeah, I believe so.
What diameter is the tube, the screw?
The pipe is
itself.
16 inch.
16.
Yeah.
I don't think it's gonna
No, yeah, I done all the deflection calculations, and even under a big heavy load, it's not going to deflect. I think more than like 1/8 of an inch or something like
Okay.
that. So
All right.
it's a real solid screw for sure. And that's about it for the amendment. Basically, as it comes out, it will dump onto a belt conveyor, and that was done by Westech, I believe. All the belt conveyors are by Westech, so they'll be able to give you more information on that right there. We'll go into some of the pre-operations type checklists, and this is more kind of stuff that I'm doing as I came by yesterday to do a static inspection and also run the system without material.
Okay.
So again, we did design the bins. I can talk a little bit about the bins. Basically, they're anchor bolted to the ground, and they're actually mounted to this corbella right here on the sides and in the center. And a lot of the seismic overturning load is taken by the corbella. There's embedded rebar and an embedded plate in the ground right here on both corners, and that will take a lot of the seismic loading. And then it gets carried into the big C channels around there for your hoop stress of your bin.
What about like a load going this way, like a lateral load? If a loader, for example, was to push some amendment trying to pick it up and it was to push on the front side of this thing.
Yeah, again, the side pieces would be able to take a lot of that
Okay.
load. The worst case scenario is earthquake loading, and is designed where if this is totally full with like a liquid like water,
Gotcha.
which is a lot heavier than the amendment, then it will be able to take it through right here.
Okay.
There's not a big enough foundation below to take the overturning load with just the foundation. It would have been like 6 foot thick.
Okay.
at the
And that's why
bottom.
it's anchored
So,
up here.
Yeah, that's why it's anchored right here. And that's why these side anchors are so important.
Okay.
And for the load back and forth, there's a plate right here which helps keep it guided and not allow it to rotate too much to one side or the other. You can see the 1 inch plate right there in the center.
Okay.
And that's basically what that's for, to help the side pieces.
Okay. If a large piece of debris got stuck on top of the protective grating, if a loader could actually drag that off, as it would get caught in there, you would expect it to jockey this thing around a little bit, and you said that that's acceptable for this anchor?
Correct, yes.
Okay.
If something does plug in the grating itself, you can get your loader bucket and go above it,
And
or
rake it.
try to lodge it and scrape it down
Okay.
off of there. You
Okay.
know, or if you get a number of plugging and it's starting to bridge, you can scrape across there and stuff. You just want to make sure that you're not lifting it up, lifting it off the supports on the top. There's not really any bolts holding it. Those things are really heavy, so they're not going to come off very easily.
Okay. Do you have a system similar to this someplace else, or did you create this?
We've done a lot of live bottom type screws for different things, but you know, this is a pretty unique facility. This is a pretty large facility, and there's not a lot of these compost facilities this size.
Okay.
Most of them are outside in open environments and stuff, so they don't need these big hoppers. We've done a lot of biosolid type hoppers.
Right.
And but as far as the amendment ones, we did one. Well, we kind of did some rework on one in Malibu, which is a compost facility. And they had some big amendment bins. We didn't actually manufacture them. We did more the biosolid bins, some of the shaftless screw conveyors and such.
Did they have a similar grizzly system, that protective grating on it? Did you notice?
No, I think they just filled it with an open top on a loader.
I'm a little concerned that the material is going to bridge on there because our stuff is going to be fairly porous. So I think if you just dropped a bucket, even though it is 6-inch minus, it may bridge up there, and we may have an issue with that. So we've talked about either altering those or removing those, or we're not certain yet. That's why I'm trying to understand the limitations of the actual auger.
Yeah.
So.
When you say bridge, do you mean accumulate on the cross members?
Absolutely. Yep.
Yeah, like a long handle squeegee like we use in set basement and stuff, and a worker can just pull it down or push it up probably fairly easy.
Yeah. What his point was is if we do get material, kind of bridging on top of the protective grate, and we could use some sort of mechanical device like a poker or something to poke it through. And that may work if it only happens occasionally, but if every bucket is bridging, then that would become a little tedious.
You can work it with a bucket straight.
If we can back drag the material, that may be fine.
You're just working in a dumping and scraping
Well-
motion. Don't just try and put it all at one time.
Yeah, feather it in and then rake it off. I think will be fine. Okay.
Well, I've seen other systems where they have grizzlies on top, and the material flows through pretty easily, and the spacing's pretty wide. So I
Okay.
don't think there should be a big issue there.
Okay.
If there is, we can work on adjusting the spacing or something like
Okay.
that. So it's mainly the bearing bars which go this way, which take a lot of the load. If we have to take some of the cross members out to get more,
That's what I'm thinking we may have to
throughput,
do.
We can probably work with you guys and do something
Okay.
like that. So that shouldn't be a big issue right there.
All right.
Let's see, so I've gone down below and all the anchor bolts are in place. All the bolts were fastened to the proper torque and tested and stuff. Let's see, I'll just kind of go into the live bottom inspection now. The screws are all in there the correct way. We rotated them, made sure the material, they're turning the right way to discharge the material and stuff. We can actually maybe start it up if you guys want to see the screws turn and listen to it. I guess the thermostats on the control panel aren't right, so it only runs for like 10 minutes before it blows out, and they have to reset it.
Okay.
So they're in the process of getting new ones in here and stuff. So that's something I just found out about yesterday.
All right.
But they can still run it for 10 minutes, plenty of time to see it, and get up on both sides of the bearings and look down the bins and such.
Okay. If one of the auger motors, as you said, they can run independently. If one is not working because it's jammed up or for some other reason disabled, is there some indicator so we can know that, or do we have to visibly find it?
Boy, I really didn't do the control system.
Okay.
I'm not sure if they have.
My understanding is that if it's kicked out because of an overload, then there'll be an alarm. I'm not sure if it's just shut off, if there will be an alarm, though we'll have to investigate that.
Yeah, I think there is just one drive for all the motors
Okay.
in the original spec, so there wouldn't be an individual alarm for each screw
Okay.
itself. Again, I'm not sure. So I think they all kick out. So the electrician was down there troubleshooting yesterday, and I think one screw was out, and it took all of them out. So I think if one screw goes out, they do all go out.
Oh, okay. I thought you said they could run independently.
Well, they can. The drives are all independent and stuff, and I'm not sure the controls how they work. If there's different variable speed, or if they can bypass it on the control panel, or what. So,
Okay.
yeah, I'm sorry. We should help you on the controls a little more. We can get Tilt and Coil, and they might be able to know a little bit more about the controls. Or get one of the controls guys down here towards the end, and we can answer a lot of the control questions and stuff while we're here.
Okay.
That'd probably be pretty helpful. Okay, so I can basically go through the initial operations type check. I've already checked the screw rotation, and the way you can tell that the screw is rotating correctly is the flight is always going to lift up the material. So if you can watch the uplifting side of the screw, and as long as it's throwing material towards the discharge, then you know it's rotating correctly. Or these guys just got a big wad of paper and threw it down there and it fell out. So that's another way you can always just check to make sure the rotation is correct if you have to redo the wiring or something like that. Again, we only ran it for about 10 minutes and stuff with the thermostats After they get that fixed, they'll do a dry test for half an hour or more, make sure that none of the bearings or drives or anything gets too hot. And I've checked for any noises and stuff. There's not really any misalignment that I can tell at all. Again, the bearings, double circle bearings can take some of that misalignment once the loading starts to happen. I did double check to be sure that if someone's down there and they have to shut it off real quick, there's a control panel, and we'll go over this when we get down there. If you turn that to the off position, it will shut it down. There's also an e-stop in the main panel on the bottom of the stairs over there that you can push, a mushroom e-stop button. But those are the really only two ways that I found where you can shut the system down real quick. Either down below the stairs or right below each of the bins. And really the screws are pretty simple. There's not a lot you really have to double check, just the bearings and the drives, make sure that there's no heating, no weird noises and stuff. And that should really be it as far as watching it. We'll go through some of the maintenance type stuff that you'll have to do on this. If you go to the back of the page right here, I actually have a routine maintenance for the amendment hoppers. And this is actually in the operation and maintenance manuals as well. I have some copies over there that we can look at and stuff. I have like 7 copies. We can go through those if you'd like to see the operation and maintenance manual in detail. I guess they're still working on checking and approving the Biosolid bin manual. The amendment one's been approved, and Tilden will have all the copies today and start to distribute those out. There's also a DVD of the whole manual, so you can pull it up on the computer as well. You know, the first greasing the bearings are pre-greased from the factory, so they won't need grease initially. It's always good after the first, say, week of operation just to go through and give them a little bit of grease, make sure there's enough grease in there.
Is that instruction in that maintenance manual?
Correct, yeah.
Okay.
Yeah, there's actually a maintenance section that just goes with the bearing itself and the gearbox and the motor and stuff.
Including the startup instructions, things like that?
Correct,
Like
yeah.
the first week and all that
It
stuff?
does
Okay.
mention that in the manual as well.
Okay, good.
Yeah. There's just a grease circle on each of the bearings there, on the pillow block and on the flange bearing itself. And it talks about, you know, what types of grease and viscosities and how much and stuff like that in the manual. It doesn't really need a lot and stuff, so it's pretty simple. A lot of people like to get those grease canisters that are pressurized. You just put it on there, it automatically greases it, and you really, it saves a lot of time just going through and stuff. They seem to be the best thing. If you have grease lines, the lines are always getting plugged. I've had a lot of customers that had problems with, you know, long grease lines and so on. It gets plugged. Unless you have like an independent system where you have a pressure gauge on each line to know if the line is plugged or not, it's really hard. You can get a false sense of security with the greasing type system there. Okay. And again, the bearings don't need very frequent greasing, you know, every 3 months and so on. If you're doing full operation and stuff. The motor bearings themselves, they do have a greaser on the top and the bottom right there. And they say do that every year. And again, you know, after the first week or two, just give it a little shot of grease just to make sure there's, you know, some fresh grease in there and so on. So you can actually peek over the side and take a look. You'll be able to see there's 2 grease zerks, one on the top and the bottom of the motor right there. And then the grease zerk, the bearing is just there on the side, right over there. I got a ladder and we just went up there. It's not too hard just to get a ladder, and you can reach most of them from just one pick with a ladder and stuff. Might just put on, I put a ladder right there and there. So other than really greasing the bearings of the motor, just double checking the tightness of bolts. You know, after the first week, just go through with a wrench and make sure that none of the bolts had loosened up is a good thing. And then otherwise, you know, just verify the torque about every year or something like that. If you get like a jamming or something like that where you're really going back and forth a lot, you can really wrench the the pillow block bearing, so it's good to double check the bearings after something like that.
Is there any post-startup inspections by Austin Mac?
I don't think there was anything, but I wouldn't be surprised if I'm down here again
Okay.
To see it with material and stuff like that. I'm
Okay.
down here every now and then and stuff, so we
Okay.
also worked on the cow manure plant and stuff, Inland Empire plant, so I've been down back and forth with that as well.
Gotcha.
And if you have any questions, feel free to give me a call anytime or call Tilden and stuff, but you don't have to go through them to get to me. You can give me a call. And in the handout itself, there's a lot of contact information right there. There's myself, Dave Martin, the chief engineer, and then Don Songres is the other engineer I work with. He did a lot of the design on this as well. He can answer questions. And if we need spare parts or something, any of us, as well as George Wilson, can help you out as far as that. Most all the parts should be readily available in stock and stuff. Dodge bearings, you can get them pretty much anywhere. Euro Drive, they're made right down here in California at Hayward and stuff like that. So all this stuff is readily available type stuff. So nothing really hard to find or from Europe or something like that.
Gotcha.
I didn't see in this information anything on Euro drives.
In the operation and maintenance manual, there's a complete section in there with the Euro Drive. There's exploded drawings of the motor, or not the motor, excuse me, the reducer, the adapter, and there's information on the motor as well. Yeah, I didn't want to put everything in here. There's got to be a lot of pages to copy and stuff, but we can go through the manuals right there, and there is everything you need to know on the reducer. And there's also, on the computer, you'll have a CD that you'll be able to go through all this stuff as well.
You providing that?
Yes.
All right, very nice.
Yeah, everything's right there in the box and stuff, so you should have that. Actually, I emailed that as well to Tilden, and you might already have that PDF file of the complete manuals. And there's a manual for the amendment bins and then a manual for the biosolid bins. We kind of kept those separate and stuff, and they're both actually on the DVD. So. Otherwise, yeah, checking the torque of the bolts, and especially the torque arm. Just make sure the bolts on the torque arm themselves are keeping tight right there. Because if that torque arm lets go, then the reducer can rotate. And the last thing you should double check is the seals themselves. The packing gland seals on the tail end. There's two bolts where you can tighten to put a little more compression on the packing, and really you don't have to really do that unless there's any leakage in there. So you don't have to worry about lubricating or anything. Just if you start to leak, you can tighten it up some, and if you can't tighten it up anymore, then you want to replace the packing in there. One thing you got to be careful about is getting the packing too tight. If you're really torquing on those bolts to get it to seal, and you can be grooving the shaft itself. So you don't want to tighten that too much. Just do about like a quarter of a turn on each bolt and wait to see what happens and stuff in there.
Is that detail in the manual as well?
Yes, there is a separate drawing of just the adjustable packing gland seal.
Excellent.
Okay, well that's about it for there. The next is I have a section there called troubleshooting. This talks about some of the basic problems you might have and what could be causing it and stuff. Excessive dust, basically the seal is failing. If it's a lip seal, you can replace that lip right there. We shouldn't really have a lot of problems with this seal right here because it's at the discharge. There's not really a lot pressing against the seal itself. And on the other end, again, it's the adjustable packing gland seal we talked about. You can just tighten it a quarter turn, and eventually once that packing is all worn out, you can just take the two bolts out, slide it back, and put two rows of packing back in without having to do anything to the bearing or anything like that. It's pretty easy to change.
So you don't have to remove the gearbox and all that?
No.
I gotcha. So
yeah, it's just one plate, you pull it back, you pull out the two rows of packing, you put two more in and put it back in.
Gotcha.
So it's really simple and easy to change. Okay, conveyor screws fail to rotate, the motor is stopped. That means there's some type of material jamming in there and stuff. So, you know, try to reverse the screw and clear the jam by going back and forth that way. And again, if one screw is doing it more than the others, then you can run the other screws and try to get the material cleared and stuff. A lot of times you can go back and forth and shred whatever big object might be in there. Let's see, the screw fails to rotate but the motor is running. That will tell you that there's a broken shaft, or the bolts connecting the shaft to the drive might be broken, although I think you break a shaft before those. This is a big 16-inch, 150-pound flange with like 12 bolts holding it, so there's no way that you're going to shear all those off very easily. Excessive noise from the bearing area. You know, the rule we usually have for bearings, if you can't put your hand on it for more than 10 seconds, then the bearing is too hot. It either needs some grease or it's starting to fail. And if you start hearing, you know, rumbling noises, you guys all know about bearings pretty well, I'm sure, then the bearing is going and stuff. So you want to try to catch the bearing before it has a massive failure, so it doesn't damage, you know, the screw or some of the other components and stuff. So even if it does fail, you know, the torque arm's going to hold the drive up, and on the other end, you're not really going to hurt anything and stuff. So it shouldn't be too bad. And again, the bearing should last a long time. You shouldn't really have any big bearing issues for years. The next page, I just kind of put recommended spare parts on there and kind of listed the part number of some of the items. The reducer itself, what the part number is. You actually have 2 reducers on site, 2 motors on site.
2 spare reducers and spare motors.
Reducers, spare motors. I believe you have 2 of each type of bearing on site as well. And Tilden has those locked up safely for you right now and stuff like that. So, and if we don't have any extra packing material here, I can easily get you some of that. So you have some spare packing.
What size is that packing material?
I think it's 5/8. I'll have to double check that. I'm not sure. I think it says in the manual as well. You can use like a graphite type packing or a Teflon impregnated rope packing with the nylon core and stuff. Both of those seem to work pretty good. And again, there's just the 2 seals and stuff, spare parts. And this is pricing from this summer, so you know how crazy steel and everything's been. So this is just kind of an idea of what the cost is right now.
Okay.
That's pretty much it for the amendment hopper right here. I guess one thing I didn't do is really go through the maintenance, and if you had to replace a bearing or a drive or remove a screw, I can kind of go through that right now with you. As far as the reducer itself, to remove the reducer, there's 2 bolts on the bottom that attach it to the torque arm. You just have to remove those 2 bolts, and after you remove those, it can rotate. You have to be careful. Then there's 1 bolt on the end, which holds it onto the shaft.
That's a key shaft, correct?
Yes, it is a key shaft. Right. We can maybe go over to the side over here, and you can see a little better from the end view. There's the black cap right there. You can kind of see it. That's where behind that, that's just like industrial, is 1 bolt. Yeah, and actually, correct, the whole thing will slide off. You can, I guess there is 4 bolts to the torque arm. I'm sorry, I said 2. There's actually 4 bolts that hold the reducer to the torque arm itself. So that basically is just sliding directly off from there. If you need to have some help in pushing it off, I believe that there's a snap ring in there and a thing where you can actually push it off. And that's detailed in the book itself, the operation manual on the book. If you look up in the top right corner, that is the oil level plug for the reducer right there. And there's drains on the side. should be able to go ahead and bring. There's also one right down there on the bottom. Yeah, on the very, you see the black cap? It's just to the left of that one bolt. It's kind of hard to see. When we get down there, you'll be able to see a little better. Yeah, there's one right down there where you can drain it. It's almost right to the top right there. Yeah, it's that very top right one. No, there's one to the left there. Yeah, that's not it. It's way up to the top there, believe it or not. That thing is plumb full of oil. It's a lot of oil. And then on that horizontal surface, there's like a little looks like a little greaser. That's actually a breather. That's the breather. There was a seal over it until just yesterday to keep the dirt out of it. So I took all those seals off. I want to make sure those little like rubber bands are not on there so they won't breathe. That's typically how all the Euro drives are. Same for the Euro drives on the shaft and screws. So I made sure all those were off so it won't overheat when it's actually running full and stuff. To get to the bearing itself and replace it, you would have to remove the drive, slide it off, and then slide the bearing off. Once you slide the bearing off, though, you'll have to support the screw underneath from the inside. So it's not really too difficult just to put a block underneath there and stuff to slide it off. And the seal, cover right here. Yeah, correct. What this is, it's a dust cover, and below that there's what we call shrouds. It's a semicircular top piece, and we can see it in the drawings themselves, that basically make sure the material from the bin isn't overflowing the top of the screw. And so you're getting a metered amount of material out of the bin into the screw and discharging up the belt conveyor itself. So you would take off this dust cover, which there's bolts across the top right there, and also some bolts on the side right there. And there's lifting irons where you can just lift it straight up and out. If I have to have a crane or something. You can even slide it to the side, and if you just access one or two or something like that. There's an individual shroud for each screw that you can lift out. So if you need to get to one screw or the other, you have to take a big piece out, and they're smaller, more manageable pieces. Those shrouds were actually made in stainless steel, so they're never going to corrode or they'll wear much better and stuff like that. And so once you have those shrouds out, you can get to the bearings or the bolts that connect the shaft to that big drive flange there. It connects the shaft flange to the screw flange right there. So that's the only way you can really get to those bolts is by going down through this right here. On the other side, you can access the bolts from inside, or on the end, we cut a hole in there and put a cap plate on it. So you can actually get a socket in from the outside to be able to remove a bolt, loosen the bolt, and you can rotate it and do another one and rotate it and do another one. So we added that kind of later on in it and stuff like that. So it's easier to get to those bolts on the far side. And really, we've already talked about replacing the bearing on that one side. It's pretty easy. It's just a pillow block. You can just slide it right off. And the seal, you don't have to do anything except undo 2 bolts to replace the packing on that seal right there. And that's really about it as far as replacing it. The motor just has 4 bolts on the top, so it's really easy to replace if you ever needed to replace it. You won't have any oil problems right there if you take it off. So that's mainly it right there. Is there any questions right now so far about maintenance or operation or? Okay. So maybe what I'll do is I'll go through the Biosolid hopper next and talk about that. Then we can go down below and get a little closer view of everything and see if any other questions come up while we're down there. We'll maybe just walk over to the Biosolid bins over there. Okay, we had one more question about the amendment bins. To remove a screw, how would you do it? The screws are designed to be removed from the inside of the bin. There's not enough room to remove it from the ends, so you definitely can't remove it from the sides and stuff. So what you would have to do is, like we talked about before, remove the dust cover itself. Then there's an individual shroud for each screw. So you can just remove the one shroud for the screw you need to replace, or all the shrouds for all the screws. Once you remove the shrouds, you can get to the 16-inch pipe, 150-pound flanges, remove all those bolts right there that connect the shaft to the screw. On the tail end, again, all you have to do is remove the bolts right there. You can access those bolts from the outside of the bin. There's a little plate with 2 bolts on it, and you can get to each one and rotate it, or you can go inside the bin and get your wrench on there and do it too.
So on the drive side, you must have a spool inside there that'll give you some room to move that screw in and out.
Correct. Yeah.
How long is that spool?
You should have enough room to where you can slide the one tail bearing over a little bit, and the tail shaft in the bearing. It's an expansion. You can slide it over a little bit and get enough room in there. And once you remove that shroud, you can kind of tip it up and bring it straight out. So yeah, it's a pretty stiff screw, so it's not going to flex at all, but there is enough room in there to do it. If you really wanted to, you could take the whole tail shaft out, then you have a lot of room in there to lift it up. But you wouldn't necessarily have to remove the tail shaft and rotate the screw up.
Lifetime of one of those screws, on average, lifetime of one of those screws?
Jim asked about the lifetime of an auger screw.
Let's see, the lifetime of the screw, you can be running 24/7 on the screws.
Say 12 hours a day.
Okay, say a 12-hour shift. It's always hard to predict wear because the materials vary so much, but typically you should get at least 5 years out of a screw. And even if it wears some, you can build up the flights or even scab material on the flights as well. So you don't necessarily have to pull it out and remove it. You can actually just replace some flights in heavily worn areas and build them up.
Well, by hard facing them?
Yeah, you can build it up with hard face, that's right.
Okay, gotcha.
But a lot of times people will just take a sectional flight, put it up against the existing one and just weld around it. So you save a lot of time by taking it in and out and so on. And you can reuse the pipe itself. You can always just cut the flights off and replace a few flights if you wanted to, and reuse the pipes and the shafts and the ends and stuff. So it isn't a total replacement even if it is worn.
Okay.
We repair screws all the time.
If we have one of those screws out, we can still run a hopper with 3.
So can we run a hopper with one screw removed?
Correct, yeah. You can still run it if you do have a screw removed and stuff.
But you need to blind off that section, like on the drive side.
Yeah, so if we had a major failure in one screw, we could probably blind off the outlet from that, or maybe we don't need to, but we could run it minus one screw while we're getting a new one in.
Yeah, you wouldn't even have to blind it off. You can just run it. The material might, bypass there. You're going to kind of build up some dead material in that area where the screw was and stuff, but the other screws will still push the material past there and discharge it, so that wouldn't be a problem at all.
These hand crank lids.
Yeah.
Is that what I'm seeing over here?
So this is the Biosolid bin right here. And again, we did all the mechanical stuff as far as the cover, the bin itself, and the shaftless screws itself is Spirax. So I'm not going to talk much about the shaftless screws and stuff, more just the bin, the structural engineering of it, and the mechanical cover.
Why is there a cover on this?
For odor control.
That is a hand crank.
Yeah. So here, I'll just kind of go through the hand crank real quick. This is the only mechanism that we really have on here to talk about and stuff, but I'll go through the bin a little bit. It's just a hand crank. It has a pawl right here to stop it from slamming back down, and to lower it, you can just crank it back and it will lower back down. There's a one-way clutch on the winch itself.
There's a policy on when to open the doors and when to close the doors, and we'll train on that at startup.
So yeah, the hand winch, you can basically crank it up. You open it all the way until you can hear the counterweights banging on there and stuff. So that's a completely open position. The lid is counterweighted with the big weights there. So once it reaches a certain point, the cable kind of gets less and then harden, and then it will kind of go over a little bit more. So there's just kind of one tipping point there in the center of gravity. Otherwise, it's sealed on the sides with these kind of pieces of belting right there for the odor. The seal on the top and the hard stops, they don't really work right now because they modified the front structure with the whole issue with the trucks. So I talked to Tilden about that, and they're going to try to shim out the bumper to where it's going to rest on here and put a longer seal on there so it will actually seal on the front as well. So you can kind of see it, how it's not totally sealing on that one over there. So that should be adjusted here as well. Now the bins haven't been lined yet. All these bins can be lined with UHMW. They're in the process of doing that on that bin right over there. And also the amendment bins themselves are going to be lined with UHMW as well.
How do you know the stop limit on the crank? Is there a certain point where you know the tension, or because everybody cranks it different with the counterweights to take over?
Yeah, basically when you hear the counterweight hit the top.
As you crank it, you'll hit the counterweights and then stop.
Yeah, it just kind of bounces a little bit and stuff. So I'll lower it a little bit and do it again.
So when you hear that,
yeah, then you know it's good. And you do want to have it fully open for when you're dumping the truck in there to make sure there's no way the truck can actually back into it and stuff. If the cover itself doesn't sit square, you know, somehow it gets hit or something moves, you can adjust how it sits with a all thread on the back there. And the manual goes in more detail about how to adjust the torque tube, that piece of pipe right there, where it lays flat on the bin. It shouldn't really have any problems and stuff. It's already been, I don't ever see it getting hit or something like that. But if it does, you do have some ability to adjust the torque tube itself. To lower it, you just go ahead and crank it backwards. It has a one-way clutch that will come down. You just basically lower it until you get some slack in the cable. You don't want to have too much slack because the cable can come out of the blocks. We actually made a little guard to prevent the cable from coming out of the blocks on the side, but we always like to, after you lower it, just put a little bit of tension on the cable and keep it taut, and you're ready to go. But once it's lowered, it should have a nice seal around all the sides right there. And again, they're going to extend this out to where the seal would rest here and put so that the hard stop will rest against here. That should be taken care of in next week or so. And there is a big ventilation pipe to be able to suck a lot of the odors out into your biofilter. And you can see right there, see that all thread there? And that helps you adjust the tension in the torque tube right there if for some reason it's not sitting down square. All the counterweights are welded in place, so they're not going to get loose or fall off or anything. There's 2 bearings on the torque tube. Really, I don't think you'll ever have to lube them, you know, maybe like every 2 years or something like that. It's not going to see much use at all, not very slow speeds and stuff. But if you wanted to, you could always just go up there and give it a shot once a year, once every 2 years or something like that. Otherwise, just take a look at the cable, make sure it's not getting frayed at all. Make sure that the cable is in the blocks. There's just the 2 blocks right there. Otherwise, that's really about it. Individual hand crank for each unit. And that's mainly it for the mechanical section of this. As far as the structural aspect of it, it's very similar to the amendment bins themselves. In the very center, there's a restraint to keep it from moving sideways. And on each side, there is the seismic overturning load tieback, which is welded to an embedment plate in here, and then the rebar goes all the way down. There's a lot of rebar in here for that overturning load right there. And then again, it does discharge into the shaftless screw conveyors, and then from there there's an incline shaftless screw conveyor as well. We did design the structure supporting the incline screw conveyors and the scaffolding and stuff. I don't think there's going to be any issues with that. And stuff, and all those drawings are in the packets as well. So that's really about it for this. We can walk downstairs and get a little closer look of the bottom of the bins and the where the e-stops are and the control panel and the bearings and reducers and stuff, and I can show you a little bit more of the packing seal and answer some more questions down there. This is one of the local control panels right here, and some of the controls right here for the screws, the amendment hoppers and stuff. And the big important thing is an e-stop right here. So one of the ways to stop the screws immediately is hitting this e-stop button right here. I think this stops all the screws down below here, the shaftless, the amendment ones, and also all the belt conveyors and stuff.
Is there an e-stop on the inlet area of the hoppers?
Not that I know of, no. I don't think there is.
Okay.
I'll ask Tilden about that and get the controls guy to answer some more about that. But not that I'm aware of up there. We'll go over to the bottom. We'll head over now to the bottom of the amendment bins.
You can also stop it from that little PLC station up there, that little HMI station.
Okay,
that's a little closer. We've had several questions about emergency stops and their locations. And one thing to remember, there is a control center up top at the actual operating floor up there.
Okay.
It's the actual SCADA system, and that has the ability to shut down all of this equipment.
Okay,
So it's within just a few feet actually. It's not an e-stop per se, but you can click a button and shut everything down. So
Okay.
there is an ability to stop everything from up there.
Yeah, I knew there would have to be somewhere.
Sure.
But that's more at the beginning of the stairs, more towards the
Correct,
hills,
correct.
Not by the entrance to the amendment or biosolids.
No, it is.
Okay.
Yeah, it's over by the stairs.
And then while we're talking about that, down over here, you can see this is the local control panel right here. And on that, there's, to open the panel, there's an on and off switch. If you turn it to off, it will shut down the screws pretty quickly. They still rotate a little bit, but it shuts it down. So there's an individual one of these for each of the amendment and biosolid bins. So if you're down here, you can just turn it off right there to get it to shut down. And inside there is the resets for the variable speed controls as well.
Okay.
I saw the guy open it up and stuff. So now I'll just kind of talk a little bit more about the drives and the bearings and the torque arms and stuff. We can see it a little better down below here. Again, here's the integral gear motor with the motor on top. You can see the 2 grease zerks for the top and the bottom bearing the motor right there. And then the reducer itself, just changing the oil per the schedule from the Eurodrive book there. Again, the bottom, that's the drain plug right there on the bottom right of that round flange. And the fill plug level is that very top right cap right there. And again, that's detailed in the book that shows you exactly where the fill plug is, the drain plug, and also the breather itself. And the amount of oil that goes in there and the type of oil. All that stuff is detailed in the operations and maintenance manuals. And you can see the cap is off of this one right here. There's the one bolt that holds the reducer onto the shaft, as well as the torque arm is not allowing it to come off. It's hard to see, but behind there's actually a flange type bearing behind the reducer. So that's your one drive support bearing. Again, you want to just double check that these bolts are tight, after running for the first couple weeks or a month. Just make sure that things didn't loosen up a little bit after running, and then just check them periodically to make sure nothing loosens up.
And those are the torque arms you're talking about right down below?
Yeah. Basically that plate, those are the torque arms itself that allow it to oscillate a little bit. And that keeps the whole thing from rotating because it's basically mounted directly onto the shaft. There's no real maintenance needed in the torque arms themselves. And again, if you had to access it, you can just put a ladder up there and you can access most all of them right there. You can just get up here if you really wanted to get on top of that cover. It can support the weight of a person, no problem. Then if you had to take the screw out or something, this is the dust cover right there. If you remove that dust cover, there's bolts along the side and bolts along the top. Then there's an individual shroud for each screw. You can just lift those shrouds out and you can get to the screw itself. So if there ever was a jam like in a shroud, you could remove the shroud and clear the jam from below without having to empty the whole bin. You can get to that shrouded area right there.
Are those nuts tacked, or you got to have a nut and a bolt come off of there?
I don't think they're tacked. They're just a nut and a bolt right there.
Okay.
So again, you can see the whole bin itself. The big C channels are designed to take the hoop stress and the seismic loading. If it starts to overturn, it keeps it in a rigid shape. It doesn't actually want to buckle the sides. That's about it for the drive right there then. We can kind of peek over here. And you can see this is the pillow block bearing. And then right here is the seal plate itself. This is where the packing gland seal is. There's the two short bolts where you can see the nut there, and then the long bolt. If you undo those two long bolts, you can slide that seal out enough to replace the packing without having to remove the bearings or anything like that.
So it's a two-piece packing.
Yes.
Okay.
Yeah, it's an outer piece that pushes the packing against the shaft and stuff. So, and again, in the manual, there's a drawing which shows it.
But it'll fit around the shaft from two sides. Okay.
Yeah.
So you don't have to come in over the end of the shaft.
No.
No.
Excellent.
It's taking, they wrap it around the shaft and push it in with the packing gland. Pull
Okay.
that back out,
Yeah.
add your next piece, push it in.
The packing
you
seal-
gotta make sure it goes in even. If it doesn't go in even, you're screwed.
Okay.
Well, yeah, the packing seal is like a one-piece type thing. So it's not a full circle. It's basically a piece and you kind of wrap it over and you can slide it in.
Correct.
And you just slide one in, another, and you put the piece on and you kind of tighten it up.
Yeah.
You just want to tighten it up evenly to get good even stress and not tighten it too much.
Yeah.
Just real loose to
Tighten it too
begin
much
with.
and end up screwing up the
And,
shaft.
yeah, exactly. There's a lot of times people just, this thing still loose.
Yeah.
Just torque it down as much as possible. They'll stop
All you
that
want is
motor.
to let the stuff from coming out.
Yeah. So this has a lot of torque, so I'm not sure you can stop it, but
Yeah.
you can easily groove it.
Okay.
So again, independent bearings right there, the grease zerk's right on top. Double check to make sure that these bolts stay torqued, and especially if you get some jams in there where you're really going back and forth and really loading these up and stuff. So I've seen that on some big hog fuel screws for boilers and stuff where they get something jammed and all they can do is go back and forth and they loosen up those bearings and boy, then they can just go out real quick. So it's really easy just to double check those. Those do have lock washers on it and stuff, so they shouldn't really have a big issue as far as backing out. They should keep torque pretty well. And everything was certified as far as the torque of the bolts and all the structural bolts themselves. That was a big issue when we were putting it together. So, I think that's really about it. The bottom of the structure, it's bolted in the bottom of the structure here and the anchor bolts. Other than that, there's really no maintenance at all. We made this bolted so it was easier to put together here. And the top part is all just sections welded together in the field. Just too big to ship in one piece or section. So, any other questions right now about
The hydraulic unit over there, is that part of yours?
No, the hydraulic is for the these belt conveyors here. I think they telescope to go into the one train or the other train right there. They're still hooking up the hydraulics. I don't think it's hooked up yet. I did hear that with the telescoping type unit.
So that one and this one should be, right?
Yeah, and this one here. If you ever had to inspect the screws, you could go onto the belt conveyor and look up from the bottom side of the screws where the discharge is. You'd be able to take a look at the bolts and there without having to undo a lot of this stuff. So just make sure, be careful of material not falling down on you and stuff. But you could easily, get your head underneath this discharge chute right here and look up at the screws and do a quick little inspection if you had to, without having to take a lot of stuff off, like the shrouds and the covers and stuff. I'm going to give you an Allen wrench that will fit the drain plug. I think it is a metric size, 17 millimeter. So I'm just going to go ahead and give you one of those so you'll have it to be able to get that off.
The material out of the amendment hoppers is activated by a ratio that's done by weight. This system, your system, doesn't have any weighing capability. That's part of the conveyor system, right?
Yes.
Okay.
Yeah. Yeah. There's no weighing ratio. It's just basically the screw will be full of discharging material in there, so you know what volume of material is coming out. They can adjust the speed.
Correct.
Of it through the variable speed drive.
Yep.
Any other questions? I've got a full-size set of drawings up there too. I can show you those if you have any more questions, or take a chance to go through the manuals and review them, see if you have any questions or whatever. And if something comes up later on, give me a call for sure, and I can talk it through with you. I can mention one more thing. I know with the reducers itself, there was a certain temperature ratio in there. I think it's 50 degrees C they have to be rated for. So we use synthetic oil in the reducers. So the oil that's in there now is the synthetic type oil. I'm pretty sure that's mentioned in the manuals as well. Here's a top view of the screws themselves. Again, they're 4 screws, completely identical. You see on the left-hand side over there is the bolt flanges that connect the shaft to the screw. So to remove the screw, you got to remove all those bolts. And on the other side over here, which is the discharge, you can see the stainless steel shrouds in there that prevent the material from overflowing the screw and into the discharge. So it's truly metered out. Those have to be removed to get the screws out. And they're removed from the above the drives, and the bolts are behind those shrouds as well. So in a minute, hopefully we'll have start up and you can watch the rotation. This is the true speed of the screws right now. It's just ramping up, so we're almost there. You can see the proper rotation to get it to discharge. If you're looking at the drive end, they are rotating clockwise. So if you're looking at the drive end, the rotation of the screws is going to be clockwise. The timing of the screws, as far as the flights from one to the other, is not a real critical thing. The flights don't have to match up from one to the next. I'll
Here,
just
Jeff.
talk about the operation and maintenance manuals right now. There's all the instructions inside this little handout and more. There's a complete set of drawings in there, including all the structural stuff of the bins, all the mechanical stuff of the screws. Typically the drawings are broken down in amendment mechanical, meaning the screws and the drives and stuff. Amendment structural, which is just the structural design of the bin itself. And the same for the biosolids. The biosolid mechanical drawings and the biosolid structural drawings. And the W drawings are for the walkway itself that are in there. In there's again all the maintenance, spare parts, troubleshooting. There's a section for the reducer, the motor, the seal. All those parts are in there. Exploded drawings of the reducer and stuff itself if we ever need a spare part or a bearing or something like that. So there's a lot of detail of information on the manuals themselves. And again, one thing I didn't really mention too much is safety. It's really important whenever you are going to work on this to lock out the controls and the power to it. Anytime you go to perform maintenance, you need to make sure it's locked out. And I always try to test run it to make sure it won't start back up when it's locked out. And just make sure there's lots of communications back and forth. So, boy, if someone ever got caught in one of these screws, it'd just be, you get shredded real quickly. Just a lot of torque, a lot of power. So, really important to lock out, make sure that the guarding and stuff is on there properly, and just be real safe around there. So, there's a section in the manual that just talks about safety, about locking out, and also talks about maintenance if you got to realign up a screw, how to do that. So take some time and go through the safety section in there and stuff.
You guys, what spare parts do you provide with the hoppers? Any?
With the hoppers, no, nothing. I mean,
So you recommend some?
for the hoppers?
Wait,
no.
Jeff asked if there was any spare parts with the hoppers. I thought you said there was two gear
Well, no,
motors
for the mechanical aspects of it, yes. You mean the structural parts of the hopper? Oh, okay. Now, as far as mechanical, we did have 2 sets of pillow block bearings, or 2 pillow block bearings, 2 flange bearings. There's 2 reducers and 2 motors. So you do have all that stuff. You should have some spare packing material as well. And again, Tilden Coil has all that stuff locked up, and we'll turn that over to you. So it's nice to be able to have that stuff. If for some reason you needed a drive, Eurodrive is a great manufacturer to work with. They can get something to you in 24, have it manufactured in 24 hours as long as they have parts.
Right.
So again, they're in California too, in Hayward, I think Northern California somewhere. And they're really good as far as customer service support. If you ever have a question, they'll have a local rep that will come down and talk to you and help you out and stuff. So, and again, give me a call if you have any questions and stuff. I've been working on screw conveyors for 12, 15 years and stuff, so, and all kinds of conveyor systems. So I've seen all the ins and outs and the problems and stuff. So if you have a question about this or even other type systems, feel free to give me a call and I'll help you out. Not a problem at all. Okay, we'll go ahead and walk down below and take a look.
That air conduit's connected to the hopper. I'm not going to talk about it. I couldn't hear, but